Hi folks, this is question 8 from section B of the Unit 3 assignment. So here we've got some function that has some unknown coefficients, and they give us some information and they want us to find B and C. Okay, so here they tell us that the function has a critical point at negative 2, 6. So we know that negative 2, 6 must be a point on this curve. So that's information number 1, and it's got a critical point there, meaning the first derivative is equal to 0 when x is equal to negative 2. Now I know that its critical point must have a derivative of 0 and not a derivative that doesn't exist, which could also be a critical point, and I know that because this is a polynomial function, so I know that the derivative always exists, since it's always going to be polynomial. So let's start again. I'm going to start by working with the derivative, since taking the derivative of f is actually going to make it simpler. It's actually going to eliminate that c. So f prime at x is equal to 3x squared plus b times the derivative of 2x. So that's just going to be 2bx. Okay, and I know that the derivative needs to be equal to 0 when x is equal to negative 2. So let's put in negative 2. Negative 2 squared plus 2b times negative 2, and so here we have one equation, one unknown, so we can actually solve for b outright. Okay, so 0 is 3 times 4, 12, and 2 times negative 2, so minus 4b. So 4b is equal to 12, b is equal to 3. Okay, so we were actually able to determine b right off the bat. Okay, so now let's input that into the function and use the fact that negative 2, 6 is on that function. So that means when y is equal to 6, x is equal to negative 2, so we have negative 2 cubed, plus, now we know what the b value is, so we might as well input that. We know b is equal to 3, and x is, again, negative 2, so squared, and then plus c, and so now we can just solve for c. Okay, so 6 is equal to, this is going to be negative 8, plus 3 times 4, plus c, so we have 6 is equal to, negative 8 plus 12 is 4, plus c, so c is equal to 6 minus 4, which is equal to 2. Okay, so there's b and there's c. So again, using the two pieces of information that were given to solve for the unknowns. Okay, so that means that our function f at x is equal to x cubed plus 3x squared plus 2. Okay, so here they ask us to sketch the graph just using the critical points and the second derivative test. I'm not necessarily picky about only using those things, but let's do it. Okay, so let's start by finding our critical points. So we know we have at least one critical point, negative 2. So let's see if there's any others. So f prime at x equals 3x squared plus 6x. Okay, so let's determine when that's equal to 0. So factor out a 3x here. So we've got x plus 2. Okay. So we know here that x can be equal to 0, or, not surprisingly, x can be equal to negative 2. Okay, and so now they want us to sketch the graph just using the critical points and the second derivative test. So I'm not even going to bother looking for zeros. I'll follow their instructions. So normally what we usually do to determine whether these are local maxes and mins is we find the sign of the derivatives and see if there's a change in sign, and from there we can determine whether it's a local max or min. The second derivative test uses the second derivative to do that. Okay, so let's find the second derivative. Okay, so here we have the derivative of 3x squared is 6x plus the derivative of 6x is 6. Okay, and what the second derivative tells us is that if the function's derivative is 0 at a particular value, okay, then the sign of the second derivative will tell us if it's a local max or min. Okay, so if the function is concave down there, then we must have a local max, and if it's concave up, we must have a local min. Okay? Excuse me. So let's calculate f double prime at 0. So that just gives us 0 plus 6 is 6. It's positive. So at x equals 0, okay, since it's concave up, we must have a min. Now let's calculate f double prime at negative 2. So here we have 6 times negative 2 is negative 12 plus 6 is equal to negative 6. So that means the function is concave down there, so we must have a max. Okay, so at negative 2, 6, since we already have that on the function, we have a max. And here let's calculate f at 0. So f at 0 is just equal to 2. So that means at 0, 2, we have a minimum. Okay, so since all they want us to use is these two things to sketch the graph of the function, I'm not going to worry about finding the zeros. So I know that at 0, 2, we have a min, and at negative 2, 6, so 1, 2, 3, 4, 5, 6, we have a max. Okay, and since this is a cubic with a positive leading coefficient, means I have to be starting from negative infinity, okay, going up to my maximum, and I'm going to have some point of inflection here, going to my minimum, and there we go. That's what my graph would look like. Okay, so again, I'm not being more precise because the only thing they asked me to use are the critical points and the second derivative test. Okay, so that's it for this.